All right, scholars, we're going to try to dissect exercise 3.13. And the reason why I like this one is because it emphasizes a lot of the stuff we've talked about in class about how to think about vectors. Okay, so first things first. In this problem, we're given two vectors, A and B, and we're told that C is the sum of A plus B. And so the way I like to think about these really is to think about C as really being, well, the sum of its components. One component in the x direction and one component in the y direction. Okay? And the beautiful thing about vectors is that the way we calculate Cx and Cy is by adding up the components of A and B. That is to say, Cx is equal to Ax plus Bx, and Cy is equal to Ay plus By. And so we're given A and B. So A is, well, it's Ax in the x hat plus Ay in the y hat direction. And we're told what these things are. So I'm just reading this out of the book here. So we're told that this is 4, no units. And we're told that this is minus 2. And just to be clear, in the text, they use the notation I hat and j hat, but it means the same thing. Okay? All right. And so, all right, and we're also told what B is. So B is also some of its components, Bx x hat plus By y hat here. And so I read off those components from what's in the text there, and I have minus 3 in the x direction, again no units, and 5 in the y direction. So basically I just have to add these up. Okay? So that tells me that C is going to equal to, well, 4 minus 3 is 1 in the x hat direction, plus minus 2 plus 5 is 3 in the y hat direction. Or Cx is equal to 1, again no units, and Cy is equal to 3. All right. All right. So that's how we write C in component form. All right. That's part A. And then in part B, it asks us to draw a coordinate system and to actually show vectors A, B, and C. And I kind of like this. So I'm going to draw a nice beefy coordinate system here. This x, y. All right, and so in order to get A, so I'm going to do A in red, I guess. Okay, I'm going to do A in, I'm sorry, blue. All right, so I go over 4 units, 1, 2, 3, 4 units here. Okay, so that's Ax, and then Ay is down 2. That's down 2. Okay, which means that. And so A looks kind of like that. I hope you can see that. Okay, if you can't see it, look at the scanned solution. Okay, but that's A. All right. And so then I'm going to draw. So A was in blue, and then we'll draw B in red. And so B is minus 3 in the x, 1, 2, 3, and up 5. 1, 2, 3, 4, 5. Up here. And so then I can draw this baby. Okay. There we go. Okay. And so that's B. All right. And last but not least, draw C in green. Okay. And C is 1 over in x, and up 3 in y. Okay, so draw that thing in there again, and so that's kind of what C looks like. Okay. All right. And finally, we're asked for the magnitude and the direction. All right. So I'm going to define that angle there as the angle phi, or phi, if you like. And so I want the magnitude, so the magnitude of C is, well, it's going to be the square root of cx squared plus cy squared, which is going to be 1 plus 9, or square root of 10. Okay. And then the angle, well, phi is going to be the inverse tangent of the height, which is 3, divided by the horizontal component, or the x component, which is 1. All right, and so I don't know that one off the top of my head, so I'm going to plug that into my trusty TI-83 here, and so tangent inverse of 3 gives me 72 degrees. And what I'm going to write on here is I'm going to write on here counterclockwise from the positive x direction. And there we